Welcome back to the deep dive. Today we are stripping everything back. And we're going to absolute ground zero.
All the way back.
We are taking the entire pyramid of modern nutrition, the grains, the leafy greens, the eat the rainbow philosophy that has been, drilled into our heads since kindergarten.
Yeah.
And we're just shoving it right off the table.
It's a clean sweep of the pantry, for sure.
It really is. We are diving into what is, I think, arguably the most provocative, controversial, and polarizing dietary intervention in health science right now. We were talking about the carnivore diet.
It's certainly a topic that elicits a visceral reaction. It challenges pretty much every foundational guideline we've been taught about nutrition for the last 50 years.
Absolutely. The immediate reaction for most people, myself included, when I first heard about this is just, it's pure skepticism mixed with a little bit of horror.
Right.
Only meat? Are you crazy? What about scurvy? What about fiber? Surely your heart will just stop mid-beat. It sounds like a fad. It sounds like something you'd see on a meme, not in a serious medical discussion.
And that skepticism is healthy. It's completely warranted. But that's exactly why we need to do this deep dive. Because while it operates on the periphery, it's gaining significant mainstream traction.
It really is.
And it's not just influencers posting pictures of tomahawk steaks. There is a growing body of multidisciplinary research, physiological, clinical, ecological, that is looking at this not as a stunt, but as a serious, potent therapeutic intervention.
Right. So the mission for today is to look past the hashtag, past the internet hype, and get into the actual machinery of this thing. We've got this incredible multidisciplinary research report in front of us, and we're going to pick it apart. We're going to look at the physiological mechanisms, what actually happens to a human body when you just cut out plants entirely.
We're going to explore the metabolic shifts, specifically looking at how the body transitions from running on sugar to running on lipids. And we absolutely have to talk about the lean mass hyperresponder, which is this fascinating and somewhat alarming phenomenon involving cholesterol.
And the trade-offs. I think that's the key word for today, because there's this serious trade-off here between potential autoimmune remission and, the long-term questions about gut health and longevity.
Exactly. It's all about weighing those risks and benefits.
So let's start with the basics, because I think people have a caricature of this diet in their heads. They picture someone just eating burger patties for breakfast, lunch, and dinner, maybe gnawing on a raw bone.
Right, the caveman stereotype.
Yeah, but the research shows it's actually a spectrum, right? It's not just a monolith of eat steak.
Correct. It's much better to think of it as a spectrum of restrictive protocols. The core definition is generally a regimen exclusively centered on animal-derived products with the total elimination of plant-based foods.
So no vegetables, no fruits, no grains, no legumes, no nuts.
Nothing from the plant kingdom. But within that definition, there is a whole taxonomy of carnivory, and each one is tailored to different health goals.
Okay, let's break those down. The report starts with something called the lion diet, which frankly sounds intense.
It is the most intense version. It is the ultimate elimination protocol. The lion diet restricts the menu to ruminant meats. So you're talking beef, lamb, bison plus, salt, and water. That's it.
That's it. No poultry, no fish, not even eggs or dairy.
Nothing. Everything else is out.
Wow. So what is the logic behind being that restrictive? Is it just masochism?
No, it's not about suffering. It's about variables. The why here is almost always severe autoimmune conditions or what we call refractory inflammation. The goal is to remove every single variable that could possibly trigger an immune response.
So why not chicken?
Well, poultry and pork, for instance, have very different fatty acid profiles depending on what the animal ate, which is often soy or corn.
Whoa.
Eggs and dairy proteins are also very common allergens for a lot of people.
Oh, I see.
So by sticking to ruminant animals, which are designed to eat grass, you are removing all those plant antigens we'll talk about later, but you're also removing those potential secondary triggers. It's about creating a physiological clean slate, ground zero.
Okay, so that's one extreme, the heal the gut at all costs approach. Then you have the nose to tail approach. This sounds a bit more ancestral.
Exactly. This is the nutrient density play. In this variation, you're eating the muscle meats, sure, but you are also deliberately including organ meats, liver, kidney, heart, bone marrow, connective tissue, the whole animal.
And this is for the person who's worried about vitamins, right? The person asking, Where do we get my vitamin A?
Precisely. If you are worried about the micronutrient gap, which is a completely valid concern, this is how you address it. Organ meats are nature's most concentrated sources of things like vitamin A, B12, iron, and trace minerals. Liver is often called nature's multivitamin for a reason.
So one is about subtraction, the other is about addition.
A perfect way to put it. The line diet is about subtraction to heal, and nose to tail is about addition to nourish.
And then looking at our source material, we have the more common ones like strict carnivore and ketovore.
Right. Strict carnivore is what you typically see online. Any animal meat, poultry, fish, eggs, maybe some dairy if they tolerate it. It's often used for rapid weight loss or just simplifying nutrition. No more decision fatigue.
And ketovore. That sounds like a hybrid.
It is. It's basically a very low-carb ketogenic diet that's almost entirely animal-based. They might allow for a few minimal low-carb plants like avocados or olives or use some spices just for culinary flexibility and, frankly, sanity. But the core metabolic engine remains animal-based.
Okay, so we know what the eating or not eating. Now let's get into the engine room. What is actually happening inside the body? Because if I stop eating carbs today, no bread, no sugar, no fruit, my body has to switch fuel sources. It can't just run on hopes and dreams.
It's a profound metabolic shift. You are essentially moving from a glucose-based economy to a lipid-based economy, and it all starts with glycogen depletion.
Glycogen being the sugar stored in your muscles and liver.
Exactly. Your liver stores carbohydrates as glycogen. It's like a fuel tank holding about 100 to 120 grams of glucose, ready to go. When your carb intake drops below about 50 grams a day, those stores start to drain.
And the report says this takes about 3 to 7 days. People call that the keto flu, right?
Roughly, yes. And that's exactly what the keto flu is. It's that transition period where your body is running out of its primary fuel and hasn't quite ramped up the machinery for the new one. You can feel tired, irritable, get headaches.
Sounds fun.
It's temporary. But once that tank is empty, you hit a crucial hormonal pivot point. Insulin, which is your main storage hormone, stays consistently low. And with insulin out of the way, glucagon, which is the mobilization hormone, rises.
And that's the signal.
That is the signal. It tells your adipose tissue, your body fat, to release non-esterified fatty acids, or nephas, into the bloodstream.
So you are literally unlocking your own fat stores for fuel. You're flooding the system with your body's own energy reserves.
Yes, exactly. Those fatty acids travel to the liver, where they undergo a process called beta oxidation to produce something called acetyl-CoA. Now, here is where it gets really interesting.
Okay.
In a normal diet, acetyl-CoA enters what's called the citric acid cycle to make energy. But that cycle requires a partner molecule called oxaloacetate, which is largely derived from glucose.
But we don't have any glucose coming in.
Precisely. So the liver is processing so much fat that it produces more acetyl-CoA than the citric acid cycle can handle, simply because it's short on that partner molecule, oxaloacetate.
It's like a traffic jam at the entrance to the power plant.
Beneficial traffic jam. The overflow of acetyl-CoA is diverted into a different pathway, the ketogenic pathway. The liver starts churning out ketone bodies, specifically beta-hydroxybutyrate, or beta-HB, and acetoacetate.
And we hear about ketones all the time in the wellness case. But in this context, they aren't just a backup fuel, are they? The report says they're much more than that.
Far from it. Beta-HB is an incredible, a super fuel for the brain and the heart. They love it. But more importantly, the research identifies it as a powerful signaling molecule.
What does that mean, a signaling molecule?
It means it sends messages to your cells and genes. For instance, it inhibits something called the NLRP3 inflammasome.
Unpack that for us. That sounds very technical.
It just means it directly turns down the dial on a key pathway of inflammation in the body. The NLRP3 inflammasome is a protein complex that, when activated, triggers a cascade of inflammatory responses. Beta-HB literally tells it to quiet down.
Wow.
It also modulates gene expression via something called HDAC inhibition. The details aren't important, but the result is a systemic anti-inflammatory effect. This is why people on this diet often report that subjective experience of stable energy. No postprandial crash. You don't need a nap after lunch because your blood sugar isn't on a roller coaster.
You just have this steady stream of high-octane fuel that is also dampening inflammation.
That's the idea.
But wait, this brings up the most common objection I hear. I hear it all the time. If I eat 0 carbs, won't my blood sugar crash? Don't I need glucose for my brain to function? I feel like I'd just pass out.
It's a myth that just will not die. The answer is a process called gluconeogenesis, or GNG.
Which means making new glucose.
Exactly. Your body is incredibly smart. It doesn't let your blood sugar crash. It synthesizes the exact amount of glucose it needs from non-carbohydrate precursors.
Like what? Where does it get it from?
You can use amino acids from the protein you eat. It can use glycerol from the breakdown of fats, and even lactate from your muscles.
So it's a demand-driven system, not a supply-driven one.
Yes, that is the key phrase, demand-driven. If you eat a bagel, that's supply-driven, you dump a ton of sugar in, and insulin has to scramble to mop it all up. Here, your liver makes just enough glucose for the body parts that are obligate users, like your red blood cells and certain parts of the brain that absolutely require some glucose. The rest of the body is happy running on ketones and fatty acids.
And the report mentions this process is expensive for the body. What does that mean?
It's metabolically expensive. It takes energy to make energy this way. To make just 1 gram of glucose via gluconeogenesis, you need to use about 1.6 grams of amino acids.
So you're burning calories just to convert protein into a tiny bit of sugar.
Correct. That conversion process burns energy. It's thermodynamically inefficient, which creates what's called a high thermic effect of the diet. This contributes to why people often feel warm after a big meat meal, the so-called meat sweats, and why fat loss can be so rapid initially. Your metabolism is literally working harder just to process the fuel.
Okay, so the metabolic engine switches to fat, inflammation goes down, and the body makes its own sugar on demand. That all sounds pretty great, but now we have to address the elephant in the room. And it is a big, fatty elephant. Cholesterol.
The lipids.
Yeah.
This is, without a doubt, the area of greatest clinical concern and the most intense controversy.
The statistics in this report are wild. It says some dieters see their LDL-C, the bad cholesterol, shoot up to over 300 milli-GDL. In traditional medicine, isn't that a call the ambulance immediately level?
Traditionally, yes. The standard view is that high LDL equals high risk of atherosclerotic cardiovascular disease, or ASCVD. If a doctor sees an LDL of 300, they are reaching for the prescription pad for a statin, no questions asked.
But the context here is completely different, right? That's what has led to this proposal of the lipid energy model.
Precisely. The lipid energy model, or LEM, tries to explain why this happens and why it might not be as dangerous as it looks.
So explain these to us. Why would a lean, healthy person suddenly have sky-high cholesterol just because they cut out carbs?
Think about the trafficking of energy. In a person eating carbs, energy is delivered via glucose and managed by insulin. In a carnivore or keto dieter, especially a lean one who doesn't have much body fat to pull from, the liver has to act as the central distribution hub for fat energy.
It has to ship the fuel out to the muscles.
Exactly. It packages triglycerides, which are fat energy, into these little boats called VLDL, or very low-density lipoproteins, and sends them out into the bloodstream to deliver fuel to the muscles and other tissues.
Okay, so the VLDL is the delivery truck full of fat.
A perfect analogy. And as the muscles and tissues strip the triglycerides off that truck to burn for energy, the VLDL particle shrinks and transforms into an LDL particle.
Ah, so the high LDL isn't necessarily a sign that the system is broken or clogged. It's a sign that the traffic is just really, really high. It's just a bunch of empty delivery trucks coming back to the warehouse.
That is the core hypothesis of the lipid energy model. The high LDL is a byproduct of high energy trafficking in a lipid-based metabolism. And this leads us to a very specific phenotype mentioned in the report, the lean mass hyperresponder, or LMHR.
It sounds like a superhero name. Who are these people?
They are typically lean individuals, usually with a BMI under 25, who adopt this way of eating and see a very specific triad of markers on their blood work.
Okay, what's the triad?
First, their LDL is very high, often over 200 milli-GDL. But, and this is the crucial, but their HDL, the so-called good cholesterol, is also very high, usually over 80 milli-GDL. And third, their triglycerides are incredibly low, often under 70 milli-GDL.
So it's high LDL, high HDL, and rock-bottom trigs.
Correct. And we have to contrast this with metabolic syndrome, which is the traditional profile of heart disease risk. Metabolic syndrome is usually driven by high insulin, and it presents as high triglycerides and low HDL. The LMHR is the mirror image of that. They have low insulin, low triglycerides, and high HDL. The only marker that traditional medicine flags as bad is the LDL.
So are they at risk? What does the data actually say? Because having an LDL of 300 sounds terrifying, regardless of what the other numbers are doing.
This is the billion-dollar question, and the research is still young. The report cites some observational data using CCTA, that's coronary computed tomography angiography.
That's a scan that looks inside the arteries for actual plaque, right? Not just looking at numbers in the blood.
Exactly. It's looking for the disease itself. And the early data from these scans suggests that LMHR individuals do not necessarily have a higher plaque burden or accelerated progression of plaque compared to controls, provided those other markers, the low trigs, high HDL, low insulin, are optimal.
That is fascinating. So it completely challenges the idea that LDL alone is the enemy.
It suggests context is everything. It suggests that perhaps LDL is only dangerous when it's in an environment of high inflammation and high insulin, where the arterial wall is already damaged and susceptible to plaque formation. However, we have to be the voice of reason here.
Of course.
The medical community is still very, very divided. We simply do not have long-term randomized controlled trial data on what happens when you have an LDL of 300 for 20 or 30 years. It might be perfectly safe, or it might be a slow accumulation of risk we can't see yet. We just don't know.
It's a high-stakes bet, for sure. But speaking of high stakes, let's talk about where this diet seems to be winning big, at least anecdotally and in some case studies. Clinical efficacy. Specifically autoimmunity and inflammatory bowel disease.
This is where the anecdotal reports are so compelling that they're finally being backed up by published case series analysis. The report details a group of 10 patients with biopsy-confirmed IBD, that's Crohn's disease, and ulcerative colitis.
And these are debilitating conditions. We're talking about people whose lives are completely ruled by pain, urgency, and constant hospital visits.
Absolutely. Life-altering diseases. And the outcomes in this case series were, well, they were remarkable: universal clinical improvement.
What does that mean in real terms?
It means cessation of bloating, cessation of diarrhea, and in some cases, the complete discontinuation of biologic medications. These are heavy-duty, expensive drugs that suppress the immune system, and these patients were able to come off them.
There was one specific case study in here that just blew my mind. A 34-year-old male.
Yes, a 22-year history of Crohn's disease. He had failed multiple biologics drugs like infliximab and ustekinumab. Nothing was working for him. His C-reactive protein, or CRP, which is a key marker of systemic inflammation, was sitting at 3.1 milli-GDL.
Which is quite high.
Yes, it shows significant ongoing inflammation.
And after he switched to this diet,
it dropped to zero point 0.1 milli-GDL within a few months. That is basically undetectable inflammation, a complete turnaround.
that is incredible. So how? What is the mechanism? Why would eating only meat heal an inflamed gut? We're always told that fiber is what heals the gut.
That's the paradigm shift. The report proposes 3 overlapping mechanisms. First, and maybe most importantly, is reduced antigenic load.
Meaning you're taking out things that trigger the immune system.
Precisely. Plants aren't just inert bags of vitamins. They have their own defense chemicals. By removing all plants, you are removing compounds like lectins, oxalates, and phytates that plants use to deter bugs and animals from eating them. In sensitive individuals, these can be major irritants to the gut lining.
So you're basically just stopping the thing that's scratching the wound over and over again.
That's a great way to put it. Second is ketogenic signaling. Remember those ketones we talked about? Beta-HB provides a direct, easy-to-use fuel source for the cells lining the colon, the colonocytes.
And why is that important?
In IBD, those cells are often energy-starved because the gut is so inflamed they can't process fatty acids from the diet very well. Ketones bypass that metabolic block and feed the tissue directly, which can promote healing.
Okay, so you stop the irritation and provide clean fuel. What's the third mechanism?
The low residue effect. Meat is incredibly digestible. The absorption rate in the small intestine is nearly 98%. That means very little waste or residue reaches the colon compared to a high-fiber diet.
So there's just less stuff down there.
Exactly. This physically reduces the volume of material passing through the inflamed area, which can reduce mechanical stress and potentially allow the mucosal lining to finally heal. It's giving the gut a complete vacation.
It makes so much sense when you lay it out like that. And there is always a but. If you give the gut a vacation from fiber, what on earth happens to all the gut bacteria, the microbiome? We are told constantly that diversity is everything.
This is the other side of the coin, the ecological dimension, as the report calls it. And it's a huge area of concern for many researchers. We're told that fiber is essential for a healthy microbiome because it seeds the good bacteria.
The saccharolytic bacteria, the report calls them.
Right, the sugar eaters, like bifidobacterium. When you switch to a carnivore diet, the research shows a rapid and dramatic shift. We're talking within 24 to 48 hours. Those fiber-eating populations crash because their food source is gone. And you see a rise in bile-tolerant organisms, specifically one called Bilophila wadsworthia.
That sounds like a villain in a sci-fi movie. Bilophila wadsworthia.
It's definitely viewed with suspicion in the literature. Bilophila loves bile, which your body produces in large amounts to digest all the fat. But in traditional studies, high levels of Bilophila have been linked to inflammation.
And what about the good stuff they produce? Butyrate.
It plummets. Butyrate is a short-chain fatty acid produced when bacteria ferment fiber, and it's critically important for nourishing the gut wall and maintaining the mucus layer. Without fiber, butyrate production drops significantly.
So wait, I'll get this straight. The microbiome profile on paper looks bad. Low diversity, high levels of a potentially inflammatory bacteria, low levels of a protective compound. But the patient with Crohn's feels amazing and has zero inflammation markers. That is a massive paradox.
It is the central paradox of this diet's effect on the gut. The report suggests that for someone with a severely damaged dysbiotic gut, removing the fiber might be more important than maintaining diversity in the short term.
Why?
It's possible that feeding the good bacteria with fiber also ends up feeding the overgrowth of bad bacteria in a gut that's already at war. So you effectively starve the entire ecosystem to stop the conflict. The big unanswered question is, can you sustain that low diversity state for decades? Does the mucus layer eventually thin out and cause problems? We just don't know.
Let's move to nutrients, the incomplete argument. We are taught we need vitamin C from oranges, calcium from milk, magnesium from leafy greens. If I'm eating just beef and water, am I going to get scurvy?
This is the most common critique, and logically you would think, yes, it's a very fair question. Meat contains very little vitamin C, maybe 10 to 20 milligrams if it's fresh and not overcooked. The recommended daily amount is much, much higher than that. Yet, clinical scurvy is virtually unheard of in the long-term carnivore community.
Why? What's going on? Are they all secretly sneaking multivitamins?
The report points to a fascinating theory called glucose ascorbate antagonism. Some really cool biochemistry. It turns out that vitamin C and glucose are structurally very similar molecules. So similar, in fact, that they actually compete for the same transporters to get into your cells, specifically the GLUT1 and GLUT3 transporters.
So if your blood is full of sugar from eating carbs, the vitamin C has to fight to get inside the cell.
Exactly. It's like a game of musical chairs, and because there's so much more glucose than vitamin C, glucose usually wins. But in a carnivore, blood glucose is stable and insulin is low. There is no competition.
So your cells can just soak up what little vitamin C is there.
The theory is that your cellular requirement for vitamin C drops drastically. You become much more efficient at utilizing the little bit you get from the meat.
And the kidneys help too. The report mentions that.
Yes, the kidneys are very smart. When your intake of a nutrient is low, they upregulate reabsorption. They stop peeing it out and recycle it. It's a powerful preservation mode.
So this all explains why they don't get scurvy. But is that level of vitamin C optimal?
That is the perfect nuance to bring up. It prevents the acute deficiency disease, it stops your teeth from falling out. But is it enough for long-term antioxidant health? Is it enough for optimal collagen synthesis over 20 or 30 years? The report is very clear. We don't know.
Okay, what about other nutrients? Magnesium, calcium. I know a lot of people who get leg cramps on low-carb diets.
Those are very legitimate concerns. Magnesium is notoriously low in muscle meat, and many carnivores report suffering from muscle cramps unless they supplement with magnesium or drink mineral water. Calcium is also very low unless you're consuming dairy or eating soft, edible bones like you find in canned sardines or salmon.
This is where that nose-to-tail argument comes back in, I guess.
It's essential. If you just eat steak, you are likely to become deficient in vitamin C, magnesium, calcium, and possibly thiamine. If you eat liver, you cover your vitamin A and copper. If you drink bone broth, you get minerals and collagen. It's not a simple diet if you want to do it right.
Let's look at the long-term systemic risks.
Yeah.
We talked about the heart. What about the kidneys? I've always heard that a high-protein diet will destroy your kidneys.
That is a persistent half-truth that we really need to clarify. The report explains this well. A high-protein diet absolutely increases the workload on the kidneys because they have to filter more urea, which is a byproduct of protein metabolism.
So it does stress them.
It increases their glomerular filtration rate. Yeah. But if you have healthy kidneys, they adapt. They actually get stronger. They hypertrophy effectively. It's like lifting weights for your kidneys. But, and this is a huge, but if you already have stage 3 or 4 chronic kidney disease, this diet is contraindicated. The kidneys are already damaged and cannot handle that extra stress.
And what about bones? There's that old idea that the acidity of meat leaches calcium from your bones.
That's the acid ash hypothesis. The idea is that meat digestion creates an acidic environment, so the body pulls alkaline calcium from the bones to buffer the pH. But the report points out that the counterargument is that high protein intake also stimulates IGF-1, which is a hormone that protects and builds bone, and it can increase calcium absorption in the gut. The data we have from long-term keto diet suggests bone density might drop a little bit initially, but then it stabilizes. It's not clear-cut.
Okay, let's talk about the big C, cancer. The World Health Organization classifies red meat as a probable carcinogen. That's a scary label.
It is, and it's based on mechanisms related to heme iron and the formation of N-nitroso compounds during digestion or high heat cooking. The major concern from a mainstream perspective is that plants usually provide the shield, the fiber, and phytonutrients that are thought to protect the gut from these potential carcinogens.
So the fear is, if you remove the shield and dramatically increase the attack by eating more meat, are you just asking for colon cancer down the line?
That is the valid fear. It's a logical conclusion based on that framework. Of course, carnivore advocates would argue that the carcinogens in meat are only problematic in the context of a high-sugar, inflammatory Western diet. They'd say that without the constant inflammation and with the gut healing we discussed earlier, the risk profile changes completely. But again, the report has to emphasize we lack the long-term data to say, for sure, we are flying blind on the 30-year outlook.
We do have some quantitative findings, though, some shorter-term studies. The report mentions a German study and a big Harvard survey. Let's hit those numbers.
The German study from 2024 was small. It followed 24 dieters. But the results matched exactly what we've been discussing. Their LDL shot up, but their HbA1c, which is the best marker for long-term blood sugar control, improved significantly. And one participant had been on the diet for 4.5 years with no clinical signs of any deficiency.
And the Harvard survey was much bigger, wasn't it?
Yes, much bigger. 2,029 adults. Now, we have to be careful. This was self-reported survey data, so there's selection bias. We take it with a grain of salt. But the satisfaction rates were just staggering. 95% reported improved overall health.
And what was that diabetes statistic? It was pretty incredible.
It was 100% of the respondents with type 2 diabetes reported discontinuing insulin after adopting the diet.
100%.
100%. Now, again, it's a survey of people who stuck with the diet, but still, that represents a functional cure for a disease that's considered chronic and progressive.
Yeah.
That is a life-changing intervention.
It really is. So let's try to bring this all together. We have a diet that contradicts almost everything we've been taught. It carries these big question marks about long-term risk, yet it seems to produce profound, miraculous results for some really sick people. What does this all mean?
It means we are dealing with a massive trade-off. The carnivore diet is a high-stakes intervention. It's a powerful tool, not a casual lifestyle choice for most. On one side, you have this incredible potential for glycemic stability and inflammation reduction. For someone with refractory autoimmune disease or uncontrolled type 2 diabetes, that can be a miracle.
But on the other side.
On the other side, you have the potential lipid risks with the LMHR phenotype and the completely unknown long-term effects of living with a fiber-free, low-diversity microbiome. It's a gamble.
So if a listener is out there thinking, my health is a wreck, I want to try this, what is the harm reduction advice? How do you do it smartly?
First, do not fly blind. Monitor your blood work. You absolutely need to know your baseline before you start, and you need to track it.
What should they track?
You need to check your lipids, and not just the standard panel. Ask for ApoB and maybe even an LPA test. Track your inflammation with HS-CRP, and definitely track your kidney and liver function.
Don't just eat ribeyes for every meal.
Exactly. Lean into the nose-to-tail philosophy as much as you can. Try to get some liver in once a week. Make bone broth. Eat fatty fish for omega-3s. Do your best to cover those nutrient gaps. And manage your electrolytes, sodium, potassium, magnesium, especially in the beginning, to avoid that keto flu.
And perhaps view it as a tool, an elimination diet, not necessarily a lifelong religion.
I think that is the wisest and safest approach for most people. Use it as the ultimate elimination diet to heal, to find your baseline of zero inflammation. Then, after 3 to 6 months, maybe consider a planned, careful reintroduction of the safest, least toxic plants. Things like peeled fruits, berries, squashes. See what you can actually tolerate.
It's just fascinating. It really forces us to question all of the fundamentals we thought were set in stone.
It absolutely does. And here's the provocative thought I want to leave everyone with. We've always been told that plants are medicine and that meat is just fuel or maybe even a danger. But the success of this diet, even if it's only for a subset of people, raises a really profound question. For some of us, with our modern stressed immune systems, are plants actually environmental stressors?
And if the lipid energy model holds true.
If it holds true, do we need to completely rewrite the textbook on cholesterol and heart disease for lean, low-carb populations? Are we on the verge of medicating what is actually a healthy metabolic adaptation rather than a disease?
Big questions that will hopefully keep the scientists busy for decades to come. Thank you for walking us through this. It's a lot to chew on, pun definitely intended.
Always a pleasure.
That's it for this deep dive. Stay curious, stay skeptical, and we'll see you next time.